All right, so section 3.2 on Introduction to Marginal Analysis. So this section is very practical, not a lot of just kind of throwing out random functions to take derivatives of and that kind of thing. Um, so a lot of word problems in this section, I guess, but nothing too complex once you kind of learn the formulas and when to use them. I don't think it's anything too complicated. So first we'll start off with average cost. So average cost, C of Q, function C of Q is the total cost of producing Q units of a good. Average cost then would be the cost function divided by Q. It's very simple there. And then marginal cost, whenever you see the word marginal in this class, we're talking about derivatives. So if you ever are asked to find something marginal, you got to take the derivative, which most problems from here on out until we get to the very last couple of sections we're going to be taking derivatives anyway. But the marginal cost is basically just the derivative of the cost function. So let's look at an example where we can use these. We have a company estimated that the cost in dollars is given by this function here. What are the fixed costs? So the fixed costs are fixed, and so they're not dependent on the variable. So the fixed costs for this case are just the constant 3,000, and so that's all there is to that one. Find the function for the average cost of each unit produced. And so all we do is we take the C of Q and divide it by Q. And so we have 3,000 divided by Q. And so then just term by term, divide this by Q. So we have plus 13 minus 0.01 Q plus 0.0000, 1, 2, 3, 4, 5 zeros Q squared. And so that is our average cost. And so now what is the average cost when 1,500 items are produced? So we just find C of 1,500 divided by 1,500. And I won't write out all the details, but we should get 6.75 for that. So just plug in the 1,500 into this function. And then marginal cost. So now we're going to take the derivative of the cost function. So the derivative of 3,000. Hopefully we're fairly confident doing these. Derivative of 3,000 is 0. Derivative of 13Q is 13. So we're just using the power rule. Multiply the exponent by the coefficient. We get 0.02 times Q, and then again multiply the exponent by the coefficient, and we get 0.000009 Q squared. So that is our marginal cost function, and then we can plug in 1,500 to that function, and we get 3.25. And so what this tells us is the cost of producing, the approximate cost of producing the next item is 325. Now D says what is the actual cost of producing the 1,500 first item. And so to get this, we are going to find, so we're going to go back to using the original cost function here and find C of 1,501 and then subtract C of 1,500. And so C of 1,501 I have is 10,128.2535. And then C of 1,500 is 10,125. And then we subtract those and we get 3.2535. And so we can see the actual cost here is very close to the marginal cost, which is kind of the approximate cost, which we're going to look at a concept here that we're kind of using when we get this. We're kind of using the idea that we're going to talk about on the next page, and we'll look at that in the next video.